Okay, this is something I call my December Mirage. Okay, so I had the inspiration to write down these two factors, y1 and y2. Okay, y1 has this common factor w squared t minus w cubed v. Okay, and it's multiplied by v minus tv one time, and then it's multiplied by tv plus v squared. Okay, now if you set u equal to minus 1 over v, then y equals 0. Okay, y2. Okay, y2 has a common factor of w squared plus v squared. Okay, it's multiplied once by v w squared plus tv. Okay, and then it's multiplied by tv times t plus vu. Okay, now if you set u equal to 1 and t equal to w, then y equals 0. Okay, these factors, I wrote them down because I saw a mirage in the v. Okay, and so what I was looking for was a solution to the cycloid. Okay, so the cycloid, these are the equations: at minus a sine t. Okay, x equals a t minus a sine t. Okay, y equals a minus a cosine t. Okay, now if you don't know, the cycloid is what happens when a wheel spins and you just pick a single point on the outer perimeter and you watch it roll. Okay, so it's like a rainbow. Okay, so so let me tell you about this equation. Okay, there's two different curves going on. Okay, the cissoid, which is y equals square root of x cubed over 2a minus x. Okay, but that curve is similar to the cycloid, but it doesn't finish the entire cycle. It only goes up to halfway on the cycloid. Okay, but it's just missing something. Okay, so we can plug the equations of the cycloid into the cissoid, and we get something that's close. Okay, these things right here, they're close. Okay, but they're not exact. Why? Because one, it's missing factors. Okay, which I think are these factors. Okay, and number two, it's missing the first power. Okay, well, what happens is in this cubic equation, okay, we put this one here, okay, and it's cubes, but what it's missing is its first power. Okay, so we add the first power, we have a more complete equation because we used these factors. Okay, now what happens when you plug y2 into the bottom, you plug y1 into the top, okay, they're cubed. Okay, but what happens is that y2 contains an identity. It's related to the curvature. Okay, well, one thing they don't tell you in school is, or they don't tell you in math class, what is this letter A? Okay, what is it? It's the curvature of the cycloid. Okay, that's the curvature. Now, what we can infer is that V and W, that the curvature is a mixture of V and W, like as in the 4 vector, when we combined x and y with sine t and cosine t, it's a mixture. So what we have going on over here, it's just a mixture of V and W contributing to the A. Okay? So on the bottom, you come up with this 2 square root of A times A, okay? For both the bottoms, okay? But what you're missing, what we're missing is a factor, okay? So when we plug y1 in, okay, then we multiply y1 over here by we have to cube the bottom. So y2 cubed over y2 cubed, these will cancel out, okay, and we'll just have something. We'll have that the bottom and the top shared a factor of square root of A and 2, and we'll end up with just a factor of t over A. Thank you very much. I'll be back with more, I promise.